Alright, wiring has begun on what I'm hoping is the permanent board for R2. As I said in prior video, a lot of work goes into lining all this stuff up and drilling the holes and smoothing the edges so nothing that's going to touch wire has got a sharp edge on it that might cut through the wire. So hopefully this doesn't turn into a pattern for yet another piece, but we'll see. Kind of wanted to just go over a little bit of an example of how things can change and how everybody's setup pretty much will be different, unless maybe you're buying an already set up electronics board from somebody that does that, which I won't be doing. This is way too much work to to do multiple times. But I based my board, as I said, on Jason Charlton's design. But along the way, there's a couple things that I wanted to do differently. And it ended up changing, obviously, the outline of the board. And so, just a couple things as I've started working on this to mention. First of all, where I'm at, which is an XT90 connector here that'll go to the battery. Positive goes to the 24 volt bus bar. Negative goes to this ground bar. So there you've got 24 volts non-fused. It will go through the 40 amp breaker switch, but it doesn't have a fuse. This is the 12 or 24 volt regulator that takes either one of those two input voltages and outputs 5 volts. The one that I connected wrong when I first tried this setup on a big piece of wood and blew something up. So this time I have double checked it. I have written red equals 24 volts right next to the thing. And I've got red going to 24 volts. And I've got this lug going to a ground bar. So this will be 24 volts in to the voltage regulator, which is correct. Output yellow to this fuse block. Output to this ground bar. So right now 24 volt comes in, 24 volts goes here. This is now 5 volts. So anything hooked up to these fuses with a positive connection and this or this ground, they're both, because they go through this and this have continuity, so you can use either one. So anything that comes off of one of these fused lugs for positive and a negative bus bar will get 5 volts. And then this wire here goes up to the top of this fuse block. This will be 24 volts if you connect it to here to either of the two bus bars. So wire gauges I'm using 10 gauge wire here that goes from this XT90 connector to the bus bar and to this bus bar. I am then using 10 gauge wire again to go up to the top of this 24 volt fuse block. And for this converter, it's hardwired, so it's whatever gauge they put in there. You can't make anything bigger, although it doesn't come with end connectors. So actually this one, my first one came with a couple Wago style connectors. This one didn't, and I want to say this one, I can't remember if this one ended with bare wires or if it already had some crimp terminals, but I ended up cutting them to the distance I wanted for this layout and putting different connectors on. The other thing you see here is the relay. This will be for the foot motors, so that when there's no power to the droid, the relay will disengage and regeneration current from the motors will not get back to the Sabertooth motor controller. And I will be hooking a switch up to it so that I can turn the switch off, which will also disconnect the circuit between the saber-tooth and the motors, so the whole rest of the droid can be powered, but the foot motors will not have power going to them. So you could push it while he's turned on, as long as the switch that controls this relay is turned off. So the main thing on the back here that I wanted to talk about is, yeah, so I'm doing a relay. Jason didn't, so right there I've got, based off his pattern, but I had to find a place to mount the relay. The ground loop isolator, which I don't have on the table right now. The one I got was recommended by the Baddeley forums, and it's a very large cylinder, and it just barely fits in here, and wires would be able to come through this hole and not hit it, but it's just, the size factor is just really not to my liking. So the one Jason has, I saw, is a much thinner profile one, and if you go on Amazon, there's tons of them that are that same profile. So I've got one in my cart. I haven't ordered it yet, but if I get that, which I'm planning to, and put it in there, it should fit in that open spot, and it will be narrower. So I'll have to drill a couple holes to secure it with a zip tie that I haven't drilled yet, but hopefully that'll fit in that space better than that large round one that was going to go there. But with the relay, trying to find a place for the relay on the back, it was pretty much either going to be there or over here, but because of the height of these connectors, and I have to put, or these tabs, and then I have to put connectors on them, which I said I'll be using flag connectors, which the wire comes out sideways and not straight up the top. The back of the droid is here, so I had to make clearance for these so they don't hit the back of the droid. So it pretty much has to go in the middle of this board, or on the front. So this is where I've decided to put it. So that altered the design a little bit from Jason's. And then he went with Anderson power poles for power in and out of his control board, and I'm using XT90 and XT60 connectors, and they mount differently. These are panel mount. Jason came up with some 3D printed mounts for his Anderson power poles, so that makes things different from my build than his. He is using diodes right now for the regeneration current back to the battery. So he has battery in, and he has a line with the regeneration current back to the battery. So when his batteries are in and the droid is turned off, he can push his, and any current generated by the motors will go directly back to the battery. I'm not doing that, so this is not going to be a battery connector. I was planning on this being power to the body, things in the body. So that was another design difference. And then the mounting required me to change things up a little bit as far as the orientation of these, horizontal versus vertical, and the space needed for the bolts and the panel mount connectors. So you can see how things, just a couple small changes, really makes it so that nobody's setup is exactly the same. Another thing I've been trying to do is not have super long bolts sticking through. This is where, for example, the Arduino is going to mount, and I have bolts coming through from the other side, and I wanted to make sure that they are nowhere near as tall as my standoff, so there's no chance of the Arduino board or whatever board has bolts underneath it grounding out to the bolt underneath it. All of these bolts that I've got in here have either a washer and a lock nut, or at least a toothed lock washer underneath them to help hold them in place, keep them from vibrating loose. Another change I made, these standoffs, I showed that the length of them, they don't poke much through the back. Well, I found once I actually started screwing them in, they did poke through the back. more than I thought. And so I took them all out to the backyard with a Dremel, with a sanding drum, and I ground off a couple millimeters off the bottom so they don't poke out. And if they do, there's nothing sharp, because they were a little bit pointy at the end when they poked out. And I didn't want anything sharp poking through, because I'm going to have things like this wire, and I don't want it anywhere near something sharp where it might cut into the wire. The next thing is, I was talking about the XT90 that I'm using to make this board so it's easy, or at least fairly easy, to remove from the Droid as one unit. These panel mount XT90 connectors work nice. They fit in here good. I'm liking that. However, these are the panel mount XT60 pieces that I bought. And if you see, they have nuts in the bottom of the panel mount. So you can't, if you mount them like this, then your bolt's going to go through the nut, through the board, and then you're going to have another nut on the bottom. And that was just like, okay, that's just not right. That didn't look good, didn't look right. I wasn't thinking that that was the way I wanted to do it. So I originally designed this so they would fit underneath. When they fit underneath, it turned out that I couldn't connect them. These two pieces go together, and it's a tight fit, which it's supposed to be, because you don't want these coming loose. So of course one-handed is going to be, there we go. They connect really well, and they have a large, it goes fairly deep into this connector to make sure there's a good connection. The problem is, when they were connected like this, I couldn't actually push this piece all the way down like this, because it would hit the bolt heads. Whatever bolts I used to tighten this from underneath the board had to go through the board and then into this and then out the other side. So the bolt heads were on top of the board here. And if you look at this piece, it wouldn't slide in to the point where it was flush where it needed to be. So I didn't realize there was a different type of panel mount XT60. So this one is more like this type. There's no nuts on the bottom. It's made to go through the top, just like these. So I realized, that goes through the top. And then I had bought, it's underneath the board, but I had bought some regular XT60s, because this one only came with this gender panel mount and the opposite gender mating piece. So I didn't have any mating pieces now, because when I bought those panel mount pieces, they only came with the panel mount pieces, not the mating pieces, but luckily I already had some. So back to the drawing board. I had to enlarge all of the holes. I reused one of the mounting holes, but had to drill a new second mounting hole, because they are, you can see they are wider than these. So if you're going to follow along, get this type of panel mount and not the other type. This is more suited for a thicker mounting than the other ones. The other type, I guess, would be good for panel mounting it in metal, something thin plastic, but not something that's about 1/4 inch thick like this cutting board. So these will work out perfectly. But it's another example of, you start getting, you think you think you've got everything ready and you're ready to go, and now all of a sudden you're buying more of these and you're buying more of these. The bolts, because I didn't want them sticking out a lot, I found that even on Amazon or your local hardware store, big box store, Ace Hardware, smaller hardware store, finding some metric sizes is difficult. 14 millimeter and 18 millimeter long bolts are practically impossible for me to find at a local hardware store. I ended up getting some on eBay because even Amazon wasn't a very good source. Because some of these bolts, it turned out 14 millimeters is just enough, just perfect to get the bolt through, lock washers and a nut. But 16 had it sticking up a bit higher than I was comfortable with, being underneath a piece of electronic circuitry. So yeah, the fuse blocks here, I ended up cutting those. Those are longer bolts that I bought, and I just cut a couple millimeters off. And then made sure they're not sharp, so they don't look all that good. I mean, they work, and I'm fine with it, rather than spending another $10 on a bag of way more bolts of the exact size. I think 18 millimeters is what I needed for here. But when you buy the box sets, they seem to come in increments of 4 millimeters. So 8, 12, 16, 20. So finding a 14 or an 18 in a box set is really tough. You end up having to buy just some 18 millimeter or just some 14 millimeter long bolts. So my bus bar bolts, I bought M5 14 millimeter. So I bought a bunch of those. The 12 millimeter that I had were just the perfect length, just like these appeared to be, but these 14 millimeter allowed me to put lock washers underneath to help keep them in place and not come loose. And then the choice, obviously, after 14 millimeter is 16 millimeter, and like I said, that's stuck up just a little bit higher than I wanted. I wanted to keep, there is a taller standoff I could have used, but I'm trying to keep this as low as possible, just because getting this in and out of the droid with the electronics on the front and back, you want to keep it as thin as possible because you have to maneuver it up, out, and you've got the dome ring on the top that has a support that goes right across the droid. So you basically have half the size of the diameter of your droid to maneuver anything out, be it batteries or the electronics board, if you don't have a back door, which I don't. So I'm trying to keep everything as low as I can. So that's pretty much just what I wanted to go over here. Starting, like I said, starting the electronics journey based on Jason Charlton's design, but along the way finding things that I wanted to do a little bit differently and some of the struggles with that. I only just yesterday and today did my first countersunk bolts. I did one here and one up here. And those are for these plastic wire loops to keep the wire in place. And the first one I did, I used a drill bit, and I went a little bit too quick, and it ended up fine. I just took a hobby knife and kind of smoothed out the inside of the countersunk area, but then I remembered, oh yeah, I have a couple countersink bits. So this is an actual countersink. It doesn't have, it's not like a screw where it's screw shaped, and when you use it, it's going to pull itself into the material, which is why the first one I did with a drill got away from me a little bit, because a drill obviously has that corkscrew design and it wants to pull itself through the material, and this material is soft. So I just lightly pushed on the drill, and all of a sudden it was further in than I thought it was. It turned out fine. Like I said, I just had to smooth the plastic out a little bit inside the hole. But then, yeah, if you are going to do countersunk bolts, it's good to have a countersink drill bit. And I've got two of these. This one here has got a broader profile. This one has a narrower profile. I used the broader one that was in the drill for these 4mm bolts, and that worked out fine. Oh, that was another thing. These connectors, if you do get these XT60 panel connectors or these XT90 panel connectors, they use M3 bolts. However, if you do go with these, the ones I originally bought, these bolts are M2.5. So there's more money that I didn't need to spend. I bought some, I think they were 14mm M2.5 bolts with flat heads, and realized that that was not going to work at all because the flat heads are too wide. I think they're going to interfere. They would interfere with the plastic here, and I ended up not going with this. So yeah, another thing where you think, well, I'm getting there. I've got all my electronics, and you end up spending more than you thought. So just a little update on the progress. I've got my main power here. This is all I've got done, so I haven't made the battery harness yet, the part that hooks up into the battery, other than this. This is the XT90 connector that will eventually go to the battery, and that plugs in right there. So that's my observations for today on doing your research on your parts. Still sometimes isn't enough, and you find when you get your parts it's not really what you need, and you need something else, which causes you to need something else, which causes you to need something else.